All right. Yesterday, we were solving equations with variables on both sides. If you weren't here, the first part of the lesson's been recorded. We're going to finish it up today. We said that anytime you have more than one variable term, there's a chance that the variable terms could cancel out. I don't think I mentioned this yesterday, but it's not just because they're on different sides. You could have two variable terms on the same side that cancel out. Oops, scoot that over a little bit. They cancel out. In this case, you would have 4 equals 0. Would you write infinitely many solutions or no solution for this one? No solution? That's right. Okay, so it's not just because they're on opposite sides. They could cancel even if they're on the same side. Anytime you have more than one variable term, there's a chance it can cancel. Okay, so if it cancels out and you're left with a statement that's true, you write infinitely many solutions. If you're left with a statement that's false, you write no solution. If you're left with the variable term not canceling out, then you can solve it just like a regular equation. Yeah, Carter? Yes. Let's move on to this next example. It says, for what value of x would both shapes have the same area? Well, how do I find the area of a triangle? Carson? Sure. So it's right like this. So it says, for what value of x would both shapes have the same area? I know that if I find the area of a triangle, 1/2 times the base times the height will give me the area of that triangle. If I want them to have the same area, that means I'd need to equal, that area would need to equal the area of the rectangle, which is x times 1, length times width. Let's simplify this up a little bit. Seth, what is 1/2 times 2? What is it? 1. Okay, so if there's just a 1 there, I could just write this as x plus 1. There's no point in writing it like this, because what happens when you distribute a 1? Nothing happens, right? You're just times it by 1. So let's just write it as x plus 1. On the other side, what's x times 1? What is it? Just x? Is this an equation where my variable is going to cancel out? It is. Yeah, you can tell because the coefficient 1 that we have in front of this x and this x is the same. So what happens is when I try to move them to the same side by getting rid of 1 to move it to the other side, it actually gets rid of both. So obviously on this side I have 1, but what do I have on the other side? What's x minus x? Xander? 0. Is there, let's see, would this be 1? Is this a true or a false statement? False. Okay, so that's not good. What's that mean my answer is going to be? Lizzie? No solution. In terms of the problem we're working on, that means there is not a value for x that you could plug in. There is no number that you could plug in for x to make these two shapes have the same area. Make sense? Okay. I'm prepared at any second for that tornado drill. While we're doing that, we can at least look at the next problem. You saw, I think it might have even been the very first homework problem from 1.3 was one like this. Okay. It says the value of the solid surface area is equal to the value of the solid's volume. Find the value of x. Let's start with the easy part. Let's do volume. What expression could I write that would give me the volume of that Christmas present? Lizzie? 9 times 4 times x. Go ahead and do the 9 times 4 for me. Okay. So 36 times x or 36x would give me the volume. I don't need to write the word volume, but I'm going to just to show you what I just did. That would give me the volume of that Christmas package. And it says that the value of the solid surface area is equal to its volume. So now I'm going to put an equal sign and I'm going to do an expression that represents the surface area of that Christmas present. Well, what I would do is I'd use my 2b plus pH formula, which I used, just did last chapter. That's why we did chapter 8 before chapter 1, because you see questions like this. And I would make this my base. So 2 parentheses, I'm going to plug in for B. What am I multiplying to get the base area? Chloe? And what is 9 times 4? 36. Okay, so there's my capital B. plus the perimeter of my base. Now, the reason I had to make the bottom the base is because the bottom and top were the only two sides where I knew the length and the width. Because I don't know what X is, I can't use the left or right side or the front and back side because I don't know that other dimension, but I do know the dimensions on the bottom side. The capital P, so there's my 2B, the capital P that I want to find now is the perimeter of that rectangle. Jace, what would the perimeter of that rectangle be? That's right. So I'm going to use 26 right here times H, and H is actually X. Did I lose anybody on that? I'm using my surface area formula. I'm plugging in 36 for the area of that base. I'm plugging in 26 for the perimeter of that base. And I'm plugging in X for H because that's the height of the Christmas present. So let's simplify that side up a little bit. This side's going to stay the same. On the right side, what is 2 times 36, Lizzie? 72. And another way I could write 26 times X is just 26X. So if you write it like that, it's not as bad as you may have thought this was going to be. I've got a variable term on both sides. I want to move it to the other, I want to move to one side. And so since I've already got a constant term right here, I don't have one on the other side, let's go ahead and just take the 26X, subtract the 26X from both sides, and move it to the other side. So the 72 is on its own side, the constant term's on its own side, and then the variable term will be on its own side. Christian, what's 36X minus 26X? Awesome. Lizzie, I see you getting your calculator out to divide by 10. Do we need our calculators to divide by 10? Sky, tell Lizzie how to divide by 10. Okay, which way am I moving the decimal? To the left one, that's right. Multiplying by 10 is as simple as moving the decimal to the right. Dividing by 10 is as simple as moving it to the left. I hear you forgot about that. It's great. You learned something important today. Even if you don't think you'll ever use surface area and volume for a Christmas package. I hear students say all the time, well, doesn't timesing by 10 add a 0 to the number? It does if I'm timesing a whole number by 10. Absolutely, that's going to be 60 because I moved the decimal one spot to the right and I put a 0 there. But what if I was multiplying 3.6 times 10? Do I make that 3.60? Isn't 3.6 the same? Exactly, it's the same. So then this is the example where I slide it over and 3.6 times 10 is just 36. Okay, so timesing by 10. What happens if I times by 100? How many times should I move the decimal point? Brady? Twice. Yep, twice. And if I divide by 100, twice the other way. That's right. Mm-hmm. I have no idea. I was told 1 o'clock. So, but we also, I think, have to do it at the same time as the high school. So maybe there's something, I don't know, those kids are still outside, so I have no idea. I don't know what they're going to get sucked up. That's what's going to happen in the vortex. We still haven't divided by 10. We did.
Attention all staff and students, we are now going to do a tornado drill. Please go to your spot.
Okay. All right, let me pause. Let me pause.
Keep this in the Zoom.
No, I'm not going to. Pause. Okay. So X equals 7.2. That's what we should have. If we have a height of 7.2, and actually I need to label inches. If we have a height of 7.2 inches, that Christmas package's volume would be the exact same as its surface area. Now, that's what we're going to do today as well. So we should be really good at these problems because posted on Google Classroom, as you might have already seen, is your 1.3 activity. And it's going to give you a series of shapes, and it's going to say the perimeter is equal to the area. Or it might say the surface area is equal to the volume. And we're going to look at problems like this right now. You might want to shrink your font size down as you're working on these problems. Give you a moment to get that downloaded to Notability. While you're getting it downloaded to Notability, I'm going to read the instructions. It says each figure has, and now when it says each figure, it's talking about each problem separately. So when we're doing example A, we're just looking at the blue rectangle. Each figure has the unusual property that the value of its perimeter is equal to the value of its area. Write an equation for each figure. then solve it for x, and then use x to find out what the perimeter and area are. We didn't have to do that, so we're going to take this just one step farther. We're going to find out what the perimeter and area are. So why don't we start with perimeter? What expression could I write that would give me the perimeter of this blue rectangle, Brady?
Plus 2, or you could use 6 plus 2x.
Okay, so okay, you've already simplified it. Okay, so I'm going to go ahead and unsimplify it, and then we'll resimplify it. So what he's saying is that we can do 3 plus x and then do 3 plus x again to get our 4 sides. And you said that's the same as 6 plus 2x. Oops, I said 6x, 6 plus 2x. Okay. Now that represents our perimeter. On this side of the equation, I'm going to write the area. To find the area of that rectangle, I would just do 3 times x. So with a variable term on each side and just a constant on the left side, it would make sense for us to move the 2x over to the left, to the right by subtracting 2x from each side. My stylus is not working very well. Subtracting 2x from each side. 3x minus 2x is x. What's left on the left side of the equation? 6. So x equals 6. So we've done 2 of the 3 parts. We've written an equation. We have solved that equation. And now we are going to find out what the perimeter and area are. Now, when it says find what the perimeter and area are, I want to remind you that they're equal. So when I find one, I'll have the other one. Would it be easier to plug x into the left side of the equation or the right side of the equation? The right side, because you're only going to have to multiply by 3. What is 6 times 3? 18. So the area is 18 feet squared. I believe it said it was measured in square feet, right? Yeah, in feet. So the area would be 18 feet squared. The perimeter would just be 18 feet. And you can double check that. If you plug 6 in right there, what's 3 plus 6?
9.
And 9 times 2? So we know we did it right. I'm going to leave example B for you to do one like that as homework. Okay. It looks like a square, but things don't often, or sometimes things look like something and they're actually not. So you want to make sure you go ahead and show your work for B. We're going to move on to F. F, it looks like it'd be just a little bit more complicated. If I wanted to find the perimeter of that shape, so again, I'm going to do perimeter on one side and area on the other side. If I wanted to find the perimeter, there are some sides that I don't know, or at least that are not given to me. Can you tell me what this side would be? Great. Sorry, Julia?
4.
4. And Julia, do you know what this side would be? 2. Okay. So now that we have our missing sides, we should be able to find the perimeter. Now, instead of making one really long expression, we know we're going to have to combine like terms. Let's go ahead and do that. Why don't we start with our variable terms? If I start on this side and I add all these sides up, you're going to notice that there's an x there, there's an x there. What's that going to make when you add x and x? 2x. What's it going to make when you add 2 plus 2 plus 4 plus 1 plus 4 plus 1 plus 2? Is it 16? I haven't even tried it yet. 16? Yeah, I think you're right. Yeah. Okay. So that expression would represent the perimeter. We've added up all the sides. On the other side of the equal sign, that expression is going to represent the area. And so what I'd do for area is I would split it into 2 parts. I would start with the area of this shape. There's my length. There's my width. So 4 parentheses x plus 1, because we're just going to times 4 and x plus 1 together. Plus, I also have to find the area of this shape. And so it looks like the length is 2 and the width is x. 2 times x 2x. Let's simplify that. If you distribute the 4, Deegan, what will you get for both of these terms?
4x and 4.
Okay. And Deegan, what do you get when you combine the 4x with the 2x? The 4x and the 2x.
6x.
Let me switch that. That one's getting really bad. Okay. So that side that I did in red is going to simplify, and this side represents the area. It's going to simplify to 6x plus 4. On the other side, we still have 2x plus 16. Now we can solve for x. Since I have a variable term and a constant term on both sides, let's move the variable to the side that's going to keep it positive. We talked about that yesterday. Is it going to be better to subtract 2x from both sides or subtract 6x from both sides? What do you think, Carter?
2x.
That's right. So if I subtract 2x from this side and from this side, that's going to eliminate the 2x on the left. And what's it going to give me, Carter, on the other side?
4x plus 4 equals 16.
Okay. I was going to say 4x, but yes. The reason I was just going to say 4x is because now in that same step, if you wanted to, in that same step, since we know the variable is on the right side of the equation, we could go ahead and move this number over to the left side. And how do you get rid of a positive 4?
Divide or subtract by 4.
Okay. What's 16 minus 4?
12.
So we just did 2 steps in one, which means I would need to show my work and what I did to both sides. Finally, we'll divide by 4. Jimmy, what's 12 divided by 4? 3. So I'm just going to write that here since I ran out of room. X is equal to 3. So I've got my equation written. I solved my equation. Now I need to find out what the perimeter and what the area, for example, F are. Would it be easier to plug into the left side of the equation or the right side of the equation? This shouldn't take you too long to think about. Which one looks like it'd be more work, Lizzie? The right side. So let's do the left side. Okay. So if I plug in 3, Lizzie, what's 2 times 3? And 6 plus 16. Perfect. So the perimeter is going to be 22 feet. And the area is going to be 22 square feet. Let's look at G. I've done a lot of talking, so I'm going to let you guys do the talking now. I know that the perimeter of this shape is equal to the area of that shape. So one expression is going to be perimeter, one's going to be area. Who wants to go first? All right, Xander, let's do perimeter.
Okay. So,
There's some sides I don't know. Can you help me fill them in? Like this side here?
that would be 3,
Good. Because it's 3 on the other side. What about this side here?
1,
What about this side here?
1,
What about this side here?
1,
And what about the one up there?
1,
Nope, not 1.
X,
Yes. Yep, let me get a better looking one here. The side up here is going to be X. We know that because if the entire length is 3X, then this plus this plus this has to equal 3X. And if that's 2X down here, then that must be another X to make it 3X. Okay. Now go ahead. What do you get when you combine your X's all up for perimeter, Xander?
6X,
Perfect. He's adding 3X and these 3X's to get a total of 6X. And then if you add all your constants together, Xander,
6.
no,
Oh, wait.
10. There we go. 3, 7. I'm sorry. 3. How about 6, 7, 8, 9, and 10? I'm just trying to save us from having to write all that long list out. We know the next step would be to combine everything, so we're just going to do it right there. That is going to be equal to, so that represents the perimeter. That is going to be equal to the area And so now I need to write an expression that represents the area, and don't have a whole lot of room to work with, unfortunately. I guess I could always shrink it down. Lower my font size, zoom in a little bit, right? Let's lower the font size down one more. To find the area of this, Maddox, what should I do?
Title the two bottom rectangles of the same as the 22x because each of those is going to be x.
That's right, because the length is x and the width is 1. So x times 1 is x, plus the other one's also x, 2x. Okay, and what about the big one?
3 times 3x.
3 times 3x. What is 3 times 3x? 9x. Okay. And what do you get when you combine? Because we can combine 2x and 9x. What do you get?
12x. Wait, 11x.
11x. We can't combine 6x and 10 on the left side because one's a constant term, one's a variable term. Okay, Jace, what should I do next to solve this? Okay. That'll leave you just 10 on that side. And what's that going to give you on the other side? Okay. Jacoby, what do I do now?
Would you divide that by
I would. And what's that going to give you? 2. So we've written the equation. We've solved the equation. Now we need to determine what the perimeter and area of that shape actually are. I don't know, actually, since I know this is 11x, it might just be easier to plug in 2 right there. I mean, it wouldn't be difficult to do on the other side, but what is 11 times 2? 22. So the area is 22 feet squared. And the perimeter, well, the perimeter would also be the same, right? And you can double check that because if you plug in 2 on this side, that's going to give you 6 times 2 is 12 plus 10 is also 22. So we know we did it right. Lizzie?
I thought with the blue meant the whole side, so
Ah.
I made it in 2. I did everything else, but I still got 2 equals x, but 16 for the perimeter area.
Gotcha. It's kind of misleading. If it was really representing the whole side, they would have centered it up, which isn't not very difficult. It's not very much farther down if they would have centered it up, right? So yeah, I only know that because I've done this one before. All right, let's flip to the second page. Yeah, Jimmy?
I have a question.
Okay,
So for the area, I put.
for the front one, for the one we just looked at? Okay,
So for the area, I did 3x times 3 plus 1 minus x.
3x times 3.
All right. I have this-
Oh, so, okay, I see. Interesting. Jimmy's using his Jimmy brain over here. And he says, why not just think of it as one big rectangle and then subtract out the piece you're missing? That would work too, wouldn't it? So you did 3x times what was essentially 4 right here then, right? Which gives you 12x. And then you subtracted out this x, and that gave you 11x.
Yeah.
And that's the same what we got, right? Also 11x for the area. Interesting. Good. Anybody else? All right, let's move on to the second part. Now we're going to do, so I've left you one to do, just so you know, I've left you B to do as homework tonight. Each solid has the unusual property that the value of its surface area in square inches, not feet now, inches, is equal to the value of its volume in cubic inches. Write an equation, solve for x, plug in x to find surface area and volume. All right, this looks like a cube, but I'm not going to make that assumption. I'd rather do the work and be sure. Let's do surface area first. The surface area formula, since I'm not sure if it is actually a cube, I'm going to go ahead and use the long one, 2b plus ph. Since we don't know what the height is, don't use the front as your base, and don't use the left as or the right side of your base. Instead, use the bottom and top as your bases because we actually know those dimensions. So I'm going to do 2, and then my capital B is going to be 6 times 6. Lucy, what's 6 times 6? Good. plus the perimeter would be 6 plus 6 plus 6 plus 6, or Emerson 6 times 4. 24. I feel like we just did this one on the Christmas thing. It was like the same numbers. And then the height is X. So all of that represents the area. That is going to be equal, bless you, to the shape's volume. And volume would be length times width times height. And Jacoby, what expression could I use to represent the volume? So what would you write? Okay. Let's simplify both of these sides. Somebody tell me what 2 times 36 is. Anybody? 72. 24 times X. 24X. 6 times 6 times X. 36X. This is like the same one, isn't it? Interesting. Okay, so now we're going to do what? Carson?
I'm going to take the X from one side to the other, so you take the 24X minus both sides to put it on the side of the 36.
Okay. What is 36X minus 24X? Carson?
12X.
Okay. Alex, what would I do now? Perfect. Alex, what do you get when you divide by 12? So was it a cube? It was a cube, wasn't it? Good to know. Okay, now we need to plug in so we can find its surface area and its volume. Well, if it's a cube, you know that the volume is going to be 6 times 6 times 6. So what's that? What's 6 cubed? Connor? Okay, and if the surface area, and that's inches cubed volume, remember we're back to cubic inches. And if the volume is the same as the surface area, that would make the surface area also 216, but we're going to put inches squared for it. So we wrote the equation, we solved the equation, we plugged X in to find the surface area and volume. Is example B a cube? No, yeah, definitely not a cube on this one. So I'm going to have to do the same method I just did here, and I'm going to leave that one for you to do as homework, which you might have some time to work on it even in class, even with our fire drill. We have one more to look at. Tornado drill, sorry. The perimeter of the large triangle is 150% of the perimeter of the smaller triangle. Find the dimensions of each triangle. The perimeter of the larger triangle. Martin, which of these is the larger triangle, the orange or purple one? Okay, so purple. I'm going to change to purple. Martin, give me an expression that represents the perimeter of the large triangle. Okay, hang on. You're getting there. There you go. Okay, there. Well, I'm going to break it up into baby steps, though. Just the purple triangle first, okay? Baby steps. Martin just gave me the perimeter of the, at least he gave me the expression, because we don't know what X is. He gave me the expression of the purple triangle, which is the larger triangle. So what we're actually doing is we're turning this second sentence into an equation. When it says the perimeter of the larger triangle, we just replace that with what Martin said, 15 plus 9 plus 2x. When it says the word is, what does is mean? Xander? Equals. It always means equals. So now we have an equal sign. And then it says 150%, which my calculator is going to want me to write that as a decimal. So Martin, what did you say 150% was? 1.5. What's the word of mean in math? Jimmy? Times, always. Is always means equals, and of always means times. So if it says 150% of, I multiply. Just like if I said I want half of, I multiply by half. So the word of means multiply, and then I'm going to take the second part of the sentence, which says the perimeter of the smaller triangle, and that's what I'm going to be multiplying 1.5 by. The perimeter of the smaller triangle, Martin, go ahead. What'd you say was the perimeter of the small triangle? All right. So there's our equation. Definitely needs to be simplified. This will be a lot easier to do once we simplify it. Why don't we start with the purple side? Dawson, what is the purple side? 15 plus 9 plus 2x simplified to? Okay. Now, I could take the 1.5 and distribute it 3 times, but instead of distributing it 3 times, why don't we go ahead and just call this 18 and just distribute it twice? Owen, I've been calling you, yeah. I was gonna say Oliver, but I'll do you next. Owen, what's 1.5 times 18? While you're doing that, I'll do the hard part and do 1.5 times x. Okay, so 27 plus 1.5x. Now it's simplified. We're ready to go ahead and start moving things around now. I haven't moved anything. All I've done is simplify. Now I get to the part where I'm going to move the variable term to one side and move the constant term to the other side. And all the while I'm doing this, I want to try to keep my variable term positive. So Oliver, should I subtract 1.5 from 2 or subtract 2 from 1.5 if I want to keep my variable term positive? Okay. And Oliver, what is 2x minus 1.5x? That's right. Since I know my variable is going to go on the left, now I know that my constant needs to go on the right. So I'm looking to get rid of the 24. Chloe, how do I get rid of that 24? Perfect. What's 27 minus 24? 3. Now I know you're wanting to get your calculator out. How many times does a half go into 1? Twice. So how many times is a half going to go into 3? 3 times that number to go in 6 times. So x is going to equal 6. Another way to think about it is if I really did write it like this, isn't the opposite of timesing by 1/2 dividing by 1/2 or multiplying it by its reciprocal? And you get 6 that way too. So a couple different ways you could get your 6, or you could let your calculator do it. All right, you've got what, 7 minutes? See if you can get that example B done right here, and see. Don't forget about probably the easier one that I left for you, which is example B. It looks like a square, but I want you to do the work and prove to me that it really is a square. If that's the case, maybe it's not the case. Go ahead and do the work anyways. Don't tell me.
What?
Don't tell me this.
No, I'm not.
Okay.
Like, once we're done doing these, like.
Nope. Nope. I trust you guys. I let you do 2 problems. If you can't do 2 problems, then you probably shouldn't be in the advanced class, right?